Welcome to the video on Section 5, Proving Triangles Congruent by ASA and AAS. We have two objectives. First, we are going to determine if triangles are congruent, and then we are going to prove triangles congruent. Just as a reminder of the ways that we've already learned to prove triangles congruent, we learned SSS, we learned SAS, and we learned HL. So today we're going to add two more theorems onto this. So the first one is the angle-side angle, the ASA congruence postulate. You could probably guess, but we're still going to write this one down. Two triangles are congruent if two pairs of corresponding angles are congruent and the included sides. Okay, so let me draw myself two triangles here. Sorry, the triangle ended up looking a little bad. Let me just fix that for us. Okay, two pairs of corresponding angles that are congruent. So here would be one pair, here would be another pair, and then the included sides. The included sides are the sides between the angles. So that would be this side and this side would have to be congruent. Okay, in this case, we have angle, side, angle, ASA. So these triangles are congruent. Okay, then we also have the AAS, angle, angle, side congruence theorem. So this one says two triangles are congruent if two pairs of corresponding angles are congruent and a pair of non-included sides. Okay, so I'm going to draw my same two triangles again. I still have two pairs of angles congruent. Okay, now I know that these are the included sides, but I need a pair of non-included sides. So for example, if these sides were congruent, then these triangles would be congruent by AAS. Okay, so let's look at example 1. It says, can the triangles be proven congruent with the given information, or with the information given in the diagram? If so, state the postulate or theorem. Okay, so in A, we currently have one pair of angles, and we have one pair of sides. Well, we have to remember that these angles are also congruent, because they're vertical angles. Okay, so our options are either SSS, HL, SAS, the old ones, or the ones from today, ASA or AAS. Okay, I don't have three pairs of sides congruent, so it's not SSS. I don't have a right triangle, so it's not HL. I only have one pair of sides, not two, so it can't be SAS. Okay, so it's either AAS, ASA, or AAS. Now I need to determine, is the side that I have the included side? Is it the side in between the two angles? We will notice no, it is not, so this is not ASA. ASA would be if we had this side and this side. Those are the included sides. So in this case, we have AAS. So I guess we should say yes, these are congruent. Yes, these triangles are congruent by AAS. Okay, in B, I currently have three pairs of angles congruent. So I have an A, I have another A, and I have a third A. Well, there's no theorem that's AAA. So no, these triangles are not congruent. Okay, and then looking at part C, I have two pairs of angles, so I have an A and I have another A, and that's all that's marked. But I need to look at context. Is there anything else that I know? Well, I know that this side is congruent to itself by the reflexive property, so that gives me an S. Looking at my list to the left, that means I either have ASA or AAS. Well, do I have the side that's included between the two angles? Yes, I do. This side in the middle is the one directly between the two angles. So this is going to be an example of ASA. And I'm going to say that these triangles are congruent by ASA. Okay, so right now, pause the video and try example 2 on your own, please. Okay, so what you should have noticed is that these angles are congruent because they are vertical angles. Now, writing down our options again, SSS, HL, SAS, ASA, AAS. Okay, it's not SSS, I don't have 3 pairs of sides. It's not HL because it's not a right triangle. It's not SAS because I don't even have 2 pairs of sides. So it's one of these two. So I need to determine, is the side that I have the included side? Is it the side in between the 2 angles? Well, the included side would be this side and this side, the sides in between the 2 angles. So it can't be ASA. So we say that these triangles are congruent by AAS. Okay, so the reason that I keep writing all of these theorems down, this video is just focusing on these 2, but after today, we're going to put all 5 of those together, and you're going to have to be able to determine which theorem applies. So that's just good practice for right now. Now, you're going to flip the page, and we're going to do a few proofs. Okay, so like I said, we're going to do a few proofs right now. So example 3, the first thing that I'm going to do is I'm going to write those givens. So I have angle FGI is congruent to angle HIG. That's a given. Okay, it's a statement, so I need to mark it in the figure. HGI, this angle, is congruent to HIG, that angle. Okay, then I have angle FIG is congruent to HGI. Again, that's a given. Okay, so FIG, this angle, is congruent to HGI, that angle. Okay, so right now I have an A and I have another A. Okay, so out of the options from today, I have ASA or AAS. So either way, I'm going to need a pair of sides that are congruent. So looking at my figure, do I know that any sides are congruent? Well, I see that the 2 triangles share this side, GI. So I'm next going to do GI is congruent to IG, which is the reflexive property. And that gives me my S. Okay, looking down the side, it looks like the theorem is going to be AAS. Okay, but we really need to look at the triangles, because as we've talked about, we're not always going to have the statements in the same order. So if I were to flip these around, it might not look like AAS anymore. So looking at the figure, do I have the included side, or do I have a different side? Well, I do have the side that's in between the 2 angles. So these triangles are going to be congruent by ASA. So triangle FGI is congruent to triangle HIG by ASA. I know that's a little confusing, but you can't always look here. That's going to give you an idea of which theorem it could be, but then you have to make sure you verify it with the triangles. So let's move on to example 4. Okay, so my first given is that angle 1 is congruent to angle 2, and that's a given. Okay, so angle 1 is congruent to angle 2. I also know that AB is congruent to DE. That's a given. And that one's already marked for me. AB is congruent to DE. Okay, so this gave me an A. This one gave me an S. Writing down my options. Okay, I have an A, so it can't be SSS. HL is only for right triangles. These are not right. Okay, so these are the 3 options I have. If I currently have an A and an S, I either need another A or I need another S. I need another pair of sides or another pair of angles. So I need to look at my figure and say, okay, what else do I know? Do I know another pair of sides that are congruent, or do I know another pair of angles that are congruent? Okay, well, looking at my figure, I know that these angles are vertical, so they're going to be congruent. So that's my next statement. Angle ACB is going to be congruent to angle DCE. That gives me an A. And this is because vertical angles are congruent. Okay, so now I know that my triangles are congruent. Okay, it's going to be a theorem that involves two A's and an S. So it's going to be one of these two theorems. Again, I can't necessarily go in that order. So I need to determine, do I have the included side? Do I have the side in between the two angles? Well, the included side would be this side or that side. So I do not have the included side, so it can't be ASA. Instead, this is going to be AAS. So I know that's confusing, but always make sure you look back at the figure, not necessarily the order of the statements. Okay, our last example. Oh, I guess we have example 4 twice. Sorry about that. Right now, pause the video and do this one completely on your own. When you come back, we'll go over it together. Okay, statements. So I have AK is congruent to CJ. Even before that, I'm going to outline the triangles that we're looking at. So we're looking at triangle ABK, this one right here, and then CBJ. Hopefully that'll give me a better idea of what I have when I write down these statements. Okay, so AK is congruent to CJ. That gives me an S. Then I have angle BJK is congruent to angle BKJ. So BJK, that's this angle, and BKJ is that angle. Okay, so the first angle is an angle in the blue triangle. The second angle is an angle in the red triangle. So this gives me an A. This is a given. And then I also have angle A is congruent to angle C. Again, that's one angle in the red triangle, one angle in the blue triangle. So that gives me another A. Okay, so I'm almost done. I have already proven that the triangles are congruent. But I need to determine which theorem. I need to determine if it's ASA or AAS. Well, looking at the red triangle only, I have an angle, another angle, and I have the included the side in between the two angles. So this is going to be ASA. So it's okay if that one was a little confusing. Please bring any questions that you have to class tomorrow. We will do a few more examples and then you guys will work on your own. Thank you. See you in class.